Hey, so I want to get you started on some stuff about that's kind of cool about a particular kind of triangles. First of all, hey, you see triangles everywhere, right? I mean, when you look around, there's a triangle just about someplace. You see them a lot in building and in artwork and different kinds of things. And I want to point out something about triangles that have a specific type called a right triangle. And so we're going to look at these things called a right triangle, and a right triangle has one right angle. Okay, in other words, it's at a 90-degree angle. So if you look at these triangles here, this one doesn't have a 90-degree angle. Okay, so it's not a triangle. Same with these two down in here, but these triangles do. There's one right here in the sandwich. There's one up here on the roof. Another one right up here in the roof. So any triangle that's got a right angle in it is called a right triangle. So here's a question for you. Which of these is a right triangle? So if you're looking around here, you might look and say, well, I don't see any 90-degree angles in here, so I don't think so there. I don't see any 90-degree angles in here, so I don't think so there. But right here, there's a 90-degree angle. So the answer is B. So, is this a right triangle? Well, without measuring, it's hard to tell. But if you look over here, you can actually get a protractor if you want, and look here. I can take this one and put it right here, and yep, that's a 90-degree angle. So there's a right triangle right there. Come on. So let's get rid of that thing, I think. So here's your right triangle right there, sorry, right angle, which makes this a right triangle. Okay. So here's what I want to show you today. There's something really kind of cool about right triangles. Here's your right angle right there, and there's something kind of amazing. And actually, this has been known for a long time. The early Egyptians knew about this. The Babylonians knew about it. They used it a lot. And then in about 300 BC, a guy named Pythagorean, yeah, they picked weird names back then. A guy named Pythagorean actually proved what I'm going to show you today. So people knew about it a long time before then, but Pythagorean proved it, and so that's why they call it the Pythagorean theorem. Okay, and a theorem is just a statement that's been proved to be true. So here's the deal with it. If you look at any right triangle, it's got two what we call legs. Okay, here's a leg here and a leg there. Okay, and the two legs always meet at the right angle. Okay, and then this side over here, this is where the Greek guys come in here and use their words. They call this the hypotenuse. Okay, you don't see that word every day. Okay, so what is it that's cool about the right triangles? Well, if you look over here, and if this side happens to be 3 inches, feet, whatever it is long, and this one is 4, okay, then there's an interesting fact about these things. As long as it's a right triangle, this one has to be 5. Okay, and here's the deal. If you take the lengths of the two short sides, 3 and 4, okay, we're going to square both of them. And again, square means to multiply them by themselves. Okay, so you get 9 here and you get 16 there. It turns out that if you add these two squares together, you get what this one is squared. Okay, so 3 squared right here, 9. 4 squared right here, 16. Add them together, you get 5 squared, 25. So I think that's pretty cool. Well, if you look over here at another one, let's just get a right triangle going here. Okay. Here's the hypotenuse, the longest side. Here's the two legs. If this side happens to be 5, and that side happens to be 12, then this one has to be 13. let's check that out. Okay, because 5 squared and 12 squared are 25 and 144. And if you add those together, you get 169, which happens to be 13 squared. Okay, so the two short sides, if you square them and add them together, you get the square of the long side. Okay, so we're going to do a few more of these here. Okay, that kind of sucks. Let me try again. Not much better, but oh well. Okay. So I'm picking pairs that I know work out to whole numbers. We'll talk about ones that aren't whole numbers later. But if this one happens to be 7, and this one happens to be 24, okay, then what's this side? Well, let's figure it out. Okay, 7 squared is 49. Okay. 24 squared. Well, you might need a calculator for that. So you can grab a calculator somewhere. Okay, I've got one right here in my hand. So 24, there's a squared button, or you can just multiply it by itself. You get 576. Okay. When you add those together, what do you get? Okay. I get 625. Well, here's the question. What number goes right here so that when you square it, you get 625? So what number squared is 625? Okay, well, one option is to start guessing numbers until you get it right. Okay, not a very fun option, but it oftentimes works. So what's a better option? Well, if you've got a calculator that can do this stuff, that'll work really nicely. What you're going to be doing is using what's called the square root. So you're trying to find what number would be squared to get 625. So you're basically unsquaring 625. So what number is going to square to get 25? Or sorry, 625. Well, the answer is 25. Well, let me show you some ways you can get there. So one option is to go to Google, type in Google Calculator, and just get the online calculator here. You can get there by hitting the square root button right here, and then 625 and equals. So there it is, 25. Another option is go to Desmos, and you'll need to either type SQRT, which you can do on a keyboard. Okay, SQRT. Oops, it looks like it didn't like the capital letter. So SQRT, and it understands that you mean a square root, and then you can just type in 625 that way. Okay, that gets you your answer. Another option is hit the online keyboard down here, hit the square root button, and then type in 625. And again, you still get 25. If you're using, here's a couple popular calculators that get used here. The TI 30XS or X2S. It doesn't work on the screen here, but there's a square button right here that squares numbers, and then if you want to do square roots, right there in blue, right above it, is a square root key. You have to hit the second key first and then square root, and then you type your number in and press equals. Or if you use the Casio calculator, they have a square root button right here. You hit the button and then type in your number, 625, and get your answer. Okay? So our result there is 25. So now we know that the answer for the length of the hypotenuse is 625. So let's do a couple more here. Okay. What if this is 8 and 15? Okay, so how long is this side right there? Okay, so let's check it out. I do know that if I square this one and square that one and add them together, I have to get what that one is squared. So let's see what we get here. Here's the first one. Here's the second one. We'll square both of them. This is 64. This is 225. And when you add those together, what do you get? Let's see, that's going to be 289. Okay, so now the question is, what number would you square to get 289? In other words, we need to square root 289. So let's go to one of these options here and find one that's going to work. Okay, this one will work here. So square root 289, press equals 17 is your answer. Okay, so now you know that length is 17. Okay, and let's do one more. What if that's 9 and that's 40? Okay, well, again, 9 squared plus 40 squared has to get this length over here. Oftentimes they use the letter C. You'll hear people say a squared plus b squared equals c squared, where a and b are the two short sides here. So it's got to equal c squared. So let's find out what it is. 9 squared is 81. 40 squared is 1600. Okay, when you add those together, you get 1681. Okay, so that's what c squared is. So let's find out what c is. We're going to have to square root 1681. Let's see what it is. So clear that. Square root of 1681, 41. Okay, so your answer is 41. All right, so I'm going to have you try a few more of them later on, but for now, let's wrap that up.